Okay, this lesson is about solving systems of linear equations by elimination. So another name for the elimination method is also called the addition method, because what you do to these two equations is you add straight down. Okay, so let's take a look at these steps right here. The first step is to write the system so that the terms are aligned. Aligned means that these like terms are aligned straight up and down, right? So our x coordinate, our x variable is aligned, our y variable is aligned, and our constants are aligned, right? And you can see the same is true about this example over here. Our y variable is aligned, x coordinates aligned, and our constants are aligned. The equal sign is aligned as well. All right, so that's step number one. Step number two, we have to eliminate one of the variables and solve for the other variable. So if you remember, I just said that another name for the elimination method is the addition method, right? So we are going to use addition to eliminate. Right, add these two equations straight down. So, and that's why these need to be aligned, right? Because they're like terms. We're going to add straight down. So 3x plus x is 4x, and negative y plus 4y is 0y's, which is equal to positive 10 plus negative 2 is 8. And when we simplify this equation, we get this. And the other part of step number 2 is to solve for the other variable. So we can see, I could definitely solve this equation, right? Just divide both sides by 4, because it's the opposite of multiplication, and x is equal to 2. All right, so that's that part. Next, we have step number 3, which is substitute the value of the variables into one of the original equations and solve for the other variable. So what that means is I need to take this 2 and plug it into one of the original equations. I'm going to plug it into this one. Let me scroll down a little bit here. Step number 3. So that equation, x plus 4y is equal to negative 2. And I'm going to take this 2 and plug it in for x right there. So 2 plus 4y is equal to negative 2. And then we subtract 2 from both sides. And this becomes 4y is equal to negative 4. Divide by 4 on both sides. Y is equal to negative 1. Okay, so the last step is to write the answers from steps 2 and 3 as an ordered pair. An ordered pair is just a point, right? It's an x coordinate, y coordinate. So you can see our x coordinate is going to come from here, which is 2, and our y coordinate is negative 1. And this, folks, is our solution. We're done. Let's take a look at the next example we have over here. So remember, the first step is to make sure they're aligned. They are aligned already. The next step we're going to do is eliminate one of the variables. Elimination method, another name for that is the addition method. So let's add straight down. Y plus 2y is 3y. And then when you add these x's together, they cancel out, which is why it's called the elimination method, because the x eliminates. And negative 2 plus 14 becomes 12. And now we can solve this equation, right? We can solve this. So let me divide by 3 on both sides, and 3 goes into 12 4 times. All right, step number 3, substitute, right? I need to take this and plug it back into one of the original equations. It really doesn't matter which one, but I'm going to plug it into the first one there. So y plus 3x is equal to negative 2. Take this, plug it in right here, so this could be 4 plus 3x is equal to negative 2. And then we subtract 4 from both sides. bring down the 3x. So the -2 and the -4, since they're both negative, add together and make -6. It's -6 negatives altogether, right? Divide by 3, and 3 goes into -6, -2 times. All right, and remember the last step is to write our coordinates as an ordered pair. So remember, that's an x coordinate and a y coordinate. In this case, the x is -2, and the y is 4. And remember, this is our solution. This is what we did this whole problem for. All right, let's try something a little harder. All right, folks, let's take a look at another example right here. We're going to solve the system by using the elimination method. And if you recall, another name for the elimination method is the addition method, because we're going to add these two equations together straight down, right? That's why our variables need to be aligned, and they are, right? And y's constants, we're all good to go. So 2x and 2x makes 4x, and then the y and a -5y makes -4y. And at this point, we can pause because one of our variables should have eliminated, right? And that didn't happen. So let's scroll back up and look at the situation that we had up here with these two examples. In this first one right here, if you see these signs in front of the 4, right here in front of the 4's, we had a minus sign and a plus sign, right? A -4 and a +4 become 0. And the same thing is true about this example over here. If you take a look at these signs, we had a +3x and a -3x, and that is why there's no x right there. Elimination. Let's go back down to our example right here. If you take a look right here, this is a +2x, and that is a +2x as well. We have two +2x's. We need one of those to become a negative. So this is how we're going to get that to happen. We are going to multiply one of these equations by a -1. So when we multiply 2x times -1, right? 2x times -1, that's going to be -2x. And -5 times -1 is +5y. And -1 times 13 is -13. Next, I'm just going to rewrite this equation down here, right? So it's going to be 2x plus y is equal to -5. So now when we add straight down, addition method, these x's are going to cancel. 5y plus y is 6y, which is equal to -18. And we can solve this equation, right? Divide both sides by 6. 6 goes into 18, -3 times. All right. I'm going to take that, and I'm going to plug it into one of the original equations. So, and I'm going to plug it into this first one right here. So it's going to be 2x plus y is equal to -5. So 2x plus -3 is equal to -5. Add 3 to both sides because that is a negative, right? The opposite is a positive. And then I'm going to bring down the 2x. This here, the -5 and the 3 make -2. And we're going to divide both sides by 2. And x, these cancel out, x is equal to -1. Great, so we got our answer, right? The last thing we need to do is write as an ordered pair. If we remember, our x coordinate always gets written first, -1, and our y coordinate is -3. Here we go, right? So this required a little bit of extra work. We had to multiply by -1 first to get our answer. All right, let's take a look at this example down here. The -5x and the 2x are not the same number. The 2y and the 3y are not the same, right? So we need to get the same number somehow. And this is how we're going to make that happen. We are going to multiply both of these equations by a number. So I'm going to eliminate the y's. So let me see here. Let me get a different color. Let's do blue. I like blue. So 2 and 3, common multiples. Excuse me, we need to find what is called the least common multiple, right? LCM. So multiples of 2 are 2, 4, 6, 8, 10, and so on and so forth. Multiples of 3, 3, 6, it's sort of just kind of my threes, right? And the next one's 9, 12, so on and so forth. But you can see that we have a common multiple, the least common multiple. That means the lowest one, 6. So I'm going to multiply this equation by, we need to multiply this by a 3 to make that a 6, right? And this one we're going to multiply by, we need to multiply that by 2 to make that a 6. But the other thing we need to take into account is that both of these are positive. Remember, if you remember from the last example, one of these needs to be a negative. So let's multiply that bottom one by -2. That's going to make that become a -6. So we need to multiply it. Remember, everything in the equation needs to get multiplied times this 3. So it's going to be negative 15x, and 3 times 2 is going to be positive 6y, and 3 times 32 is going to be 96. Negative 2 times 2 is negative 4x, and negative 2 times 3 is 6y, and negative 2 times 10 is 20, negative 20. So it changes all the signs, right? Oop, I forgot to change this one sign here. Let's fix that. There we go. So now let's add straight down. So that becomes 19x, negative 19. These y's cancel out, and this makes 76, right? Divide by negative 19 on both sides. X is equal to, I'm pretty sure it's going to be negative 4. Negative 4, and we're going to plug it into the second equation. And I'm only choosing that because I personally think this is the easier one to plug it into. You can plug it into either one. So 2 times negative 4 plus 3y is equal to 10. That's going to be negative 8 plus 3y is equal to 10. Add 8 to both sides. 3y is equal to 10 plus 8 makes 18. Divide by 3. And y is equal to 18 divided by 3, which is 6. All right, last step. X coordinate, y coordinate. Our x coordinate is 4, negative 4, and our y coordinate is 6. There we go. This is our solution. Let's solve. So this one, take a look at it. We need the same numbers, so you have to decide if you want to solve for the y's or you want to solve for the x's, or excuse me, which one you want to eliminate. I think it's easiest or best if we eliminate these x's. And to eliminate the x's, I'm going to multiply. You see this is already a negative, right? I just got to multiply this by 3 because that there is a positive 3. So let me rewrite this over again. So 3 times negative x is negative 3x. 3 times y is positive 3. And 3 times negative 2 is negative 6. Let me bring this one down. So it's 3x plus 2y is equal to 6. Now when we add straight down, remember this is the elimination method, the 3 x's will cancel out. The 3y plus 2y makes 5y is equal to 0. Divide by 5, and 5 goes into 0 times. And let me take the 0 and plug it into the second equation right here. So that is negative x plus y is equal to negative 2. So it goes right there, right, for the y. So negative x plus 0 is equal to negative 2. So negative x is equal to negative 2. Divide by negative 1 on both sides, and x is equal to 2. 2, 0. This is our solution. Here's our last problem. All right. So let's look at the problem and make a decision on which one we want to simplify. Which one we want to eliminate. We want to eliminate the x's or the y's. I think it's probably better if we eliminate the x's. So I'm going to multiply. I see my common multiple between 2 and 3 is going to be 6, right? That's the least common multiple. So let me multiply the top one by a 3 and the bottom one by a 2. So the top one becomes 6x, right? And then 3 times 5 is 15y, and 3 times 26 is 78, and 2 times negative 3 is negative 6x, and 2 times negative 4 is negative 8y, and 2 times negative 25 is negative 50. And now let's add straight down. The x's cancel out. This is going to make 7y, which is equal to 28. If you add these two together, right? Opposite signs, you actually subtract. Divide by 7. 7 goes into 28 4 times. All right. That's half the battle. For G.I. Joe. Take this and plug it into the first one. Plus 5y is equal to 26. So that 4 is going to get plugged. Let me undo that. That 4 gets plugged into the y right there. So 2x plus 5 times 4 is equal to 26. So 2x plus 5 times 4 is 20, which is equal to, subtract 20 from both sides. 2x is equal to 6. Divide by 2, x is equal to 3. Remember, the last thing we need to do is to write this as an ordered pair. However, you do not need to write this as an ordered pair if you had a word problem. If you would like to see some examples of word problems, comment below and I'll make a video.